Hello all, welcome back to the fourth session of the JavaScript object-oriented programming series. In this part, we'll be discussing various ways of instantiating objects in JavaScript. We'll be going through all the three and comparing the same. So let's start. The three models of instantiating objects are object literal, classical model, and the prototypal model. In the first case, it is a direct instantiation of objects without any constructs being used, and the classical model very much resembles the way the classes in object-oriented programming are, and the prototypal model is something that we have already seen in the previous sessions, but we'll cover more in depth. Object literal. In this approach, you construct your objects without defining any templates for the same. You directly define the properties and the methods for those objects at the same time that the object is instantiated. So let us verify it with an example. Arrays are a typical way of instantiating objects. So before this, let us start with a simple example. So this is a very simple way of instantiation of an object. This part we have already covered it. So in this case, what we do is basically define properties like name and version at the same time as when the object is getting created. So we can alert for those values. Probably I missed out on something. Okay, so this operator should not be used in this case. Okay, so you would see that the properties name and version are specified and created at the time when the object is instantiated. The problem with this approach is that you would have to repeat the same set of properties for each and individual objects that you're going to create down the line. So let us assume that we are having another object that we need another object of the same properties but with different values. In this case, though the set of key value pairs are the same across these two objects, object 1 and object 2, we still continue to define them for individual objects. This problem will explicitly be more explicit when we define methods which will have the same set of implementations across the objects. So in this example, though the definitions of display function is remaining the same across the two objects, object 1 and object 2, we still have to repeat the same across those objects. This is a tedious work, as any change in the implementations of those methods will impact all objects. Okay. Some property was getting a value of G1 display function undefined. Okay, so we don't have to alert this part because there is already an alert of alert method which is given inside the display function. So let's refresh G1, and this gives you the second implementation. So the whole point is, though the methods are common or the same across the two objects, we will have to repeat the implementation of the same across them to ensure that they function the same. If we assume object 1 and object 2 belong to the same class of objects, so this will be a tedious work. This is the way object literals work. So to avoid this way of instantiating objects, we have the concept of constructors in JavaScript, which will help us define the properties and the methods only once in one place, and the remaining of the objects need not worry about the implementation of the specific methods. Neither does it have to worry about the specific properties. If they do not initialize them, it will still remain as undefined or null. But on the whole, individual objects need not worry on the specific properties or the methods. In this case, so let us look at an example before going into constructors of our own custom classes. We will inspect a constructor that is provided by JavaScript for arrays. So the same, I'll just rename this file. So in this case, you will see an example of the way arrays are instantiated with implicit constructors. And we have already gone through the various APIs of the object in the previous session. So now this will just exemplify them. So let us look at one by one the alerts. So object.keys of R, this would give me 0, 1, which are the key indexes of these array elements. This square brackets is the implicit constructor that I was speaking about. JavaScript, the JavaScript engine in the browser takes care of instantiating. Once it sees a square brackets, it has an array. So object.keys return me the indexes of the elements in those arrays. So the next one is comparing whether the prototype of the array is the same as the array.prototype. So I can directly have a replacement here. So P stands for object.prototype of, get prototype of. The third one, this happens to be true. The third one is whether we are checking whether array is an instance of array object. ARR, is it an instance of array object? So that becomes true. And down the hierarchy, as array is also an instance of the base object object. So the hierarchy sets up that ARR still is an instance of an object. And the fourth part is verifying the prototype. Again, whether it comes under the hierarchy of object. Okay, as you see, the prototype, the third level of prototype for ARR goes as null. The reason being, object is the super object of all the objects in JavaScript. And again, as I am displaying the object.keys, this do not return anything. And now you will observe that ARR was constructed using an implicit constructor of array. Now, any methods that you introduce at an higher level of that array object, say, as we have observed, object is a super object of array. Now, as you introduce any new methods to that object, array does also have access to that method. So as you introduced a new method FOO at the object level, your third level of object, that is ARR, now has this new feature of invoking the foo method. So let us verify it again. Now this time it stopped execution here, as there was no method called foo defined for array. That's the reason why it stopped execution and you did not get a message of yes. So this is about arrays, the implicit constructors provided by them. Okay, so now to address the problem of data sharing across objects, we'll be introducing the concept of constructors as we saw in arrays. Now we can define our own constructors for our custom classes and custom functionality. So the two types in which this can be done is the classical model and the prototypal model. In the classical model, you use the approach more or less of an class aspect of object-oriented programming language, and in the prototypal model you will be using the objects themselves to instantiate other objects. So let's see them one by one. So in this case, this is an example of a classical model wherein we define a function and specify two new properties inside the function, initialize and describe. This function acts as a template for me for my objects that I'll be creating. I need not anymore worry about specifying these methods, that is repeating these methods for individual objects at the object level. So in this case I have a variable Jane pointing to %proto, an instantiation of %proto, and then I specify a property for Jane, the name of it, and then I invoke the method of Jane. So in this way I use a new operator to instantiate objects in the classical model, and I specify each and individual property in my function with this operator. So this is the classical model. Constructor, they expect it to be a factory that creates different objects of the same class. And in this example, you would have seen that the prototype property of the constructor is what that will equal the proto property of the Jane object. So this is how the hierarchy and dynamic method dispatching will happen by that whenever there is a call to the describe method, the proto property of the Jane object will be used to go up the hierarchy to identify whether the method is in the hierarchy or not of the objects. And instance of could be used to verify whether Jane belongs in the hierarchy of %proto. Same would hold good for an object, as %proto comes in the hierarchy of object being the superclass of all the objects. So it's like object person proto, and Jane is the instance out of it. So if you call instance of operator on Jane over person proto or object, it will still result to the same true expression. This is very similar to constructor. Jane dot, you could call the same through this object dot prototype dot is prototype of Jane. So let me put alerts to identify and distinguish them. This needs some corrections. So person named Jane, then the expression evaluates to true, then the expression evaluates to true, true and true. That is object.prototype is the prototype of Jane. This also holds good for person proto. Person proto, let me name it as 6. True, true. Alert 5 gave me true and alert 6 gives me true. But there is something a catch to this. We would have seen a API called get prototype of. Yes, this one. So let's verify this part. Object, and now I can verify whether it comes under the hierarchy of person proto. So this evaluated it to true. But the same is not true when it is object.prototype. What this means is, get prototype of gives you the immediate parent of Jane, and it does not evaluate, or it does not take into consideration the complete hierarchy of Jane. So as said, that the classical model uses equals operator and semicolons to separate the member variables. Proto is the special property introduced in all individual objects that are instantiated for each of those classes. And ECMAScript 6 is the one that is going to get us the actual class keyword in JavaScript. We're waiting for it. So that was about the first approach for instantiating objects in JavaScript. The second approach is wherein it is called as the prototypal model. It uses a different structure for instantiating objects. Instead of the new operator, you will be finding a different set of operators in it. So this is the example for the same. So in this example, you will see that there are this is syntactically different from the classical model. It uses a colon operator and it uses commas to separate the individual member variables of the person proto class or object, and you instantiate a new object out of it using object.create method, which is again available from the object class. As said, this was one of the APIs that I told that we'll discuss later, and this is the approach that is used to instantiate objects. And then we assign a new property to it, and then we call the method on describe. Just going to return us the display method of it. So this expects you to use the colon operator and the comma operator to separate the member variables. Yes. So in this case, let us see the constructor part of it. Object was the one that was used to instantiate the Jane object in this case. And person name dot prototype is another expression that we could use. Okay, so finally touching upon this operator. This operator will be applicable with respect to both the classical model and the prototypal model. In this case, as you would see, that Jane.name is assigned a property of Jane. This operator, when you call a describe method, after assigning the name property to Jane, the describe method tries to access the name property using the this operator. So what happens is, on call to describe method, this operator gets set to the object that is invoking the method. So Jane is now called as the receiver of the call, and the properties specific to Jane will be used to display or return in this method. So now if you have a different object with a different set of properties, the first time it returned Jane and Jack, and it so happens because on call to describe method, the value in this case, the receiver of the call will be Jane, and on call to this one, the receiver of the call will be Jack. So in the thus differentiating the two objects using the this operator. So in this session, we went through the ways of instantiating objects in JavaScript. We also went through each and individual of them, the object literal way of instantiating objects, the classical model of doing the same, the prototypal model of doing the same, and finally we touched upon the this operator, which is set to the object that is invoking the method, which is called as the receiver of the call. The object is called as the receiver of the call. In the upcoming session, we'll be going through object-oriented principles in depth, addressing all the object-oriented principles, how exactly we will be achieving each one of them. Thanks.